So in the previous lecture, we looked upon that how and why limits are important. In order to assess the output at a given specific input, we need to understand and we need to evaluate and assess limits.
Limits are primarily assessed in order to identify ambiguity at a point in a function using neighborhood.
Welcome to lecture 2.1. We have already seen limits. Now we'll be looking to if the limit is being approached from the left hand side, that is from the smaller value to that value, and from the right hand side, that is from the higher value to that value, whether these two limits are reaching or revealing the same output or not. If the limit from the left hand side and from the right hand side, they both are equal, then we are going to say that limit exists for that function at that point. So let us look to evaluation of the limits. Let our function be equal to 2x square plus 3x plus 4. If we wish to assess the limit when the input is approaching 2, we can directly substitute the value over here, that is 2 square, because this is x square, and the input is approaching to 2 plus 3. Again I substitute this value over here plus 4. So we can very well say that limit x approaching 2 for this particular function, that is 2x square plus 3x plus 4, is given by substitution like this, that is it becomes 8 plus 6 plus 4. So this is nothing but 18. Now this, because we have substituted the value, thus is known as the evaluation of limits by substitution. This is one of the methods. But now look to a scenario in which, say for example, the function is equal to x square minus x minus 6 and divided by x cube minus 3x square plus x minus 3. If we try to do it in the similar fashion using substitution out here, that x is approaching 3. Try to do that. This becomes 3 square minus 3 minus 6 divided by 3 cube minus 3 square plus 3 minus 3. If you look to it, that this becomes 9 minus 9 equal to 0. This becomes 27 minus 27 plus 3 minus 3. This again becomes 0. Now over here the substitution doesn't work. So how do we tackle this? Look to this numerator and look to this denominator. We can basically put it in a fashion that limit when x is approaching 3, we can very well say that this x square minus x minus 6 by x cube minus 3x square plus x minus 3. For this approach, for when the input is approaching 3, it can be very well rewritten to that x is approaching 3. It can be very well written that this can be factorized into x minus 3 and x2 divided by the denominator can also be factorized to x square plus 1 and x3. Now we have factorized the numerator and we have also factorized the denominator. I can very well look to this that once these two values can be cancelled.
In this example, we are cancelling x minus 3 from both numerator and denominator because when x is approaching 3, it is actually creating a problem for us.
These two values can be very well cancelled, and finally this is simplified to limit when x is approaching 3 to x2 and x square plus 1. the function, the given function is then factorized. We have calculated the factors and come out with this. Now over here we can very well substitute this, and at this particular point of time we can substitute 3 minus 2 and then 3 square plus 1. So the limit, when the limit x is approaching 3, so for this particular limit, the function which was there in the focus, we have factorized and found out that the limit comes out to be by 10. This method is known as factorization. So there is one, we have substitution, and the other we have factorization. We look to another method. We have seen that limits can be evaluated either directly by substitution, or when the substitution is not working, you need to factorize, and can be done by factorization. Look to another scenario where the function fx is equal to x square minus 16 divided by under root of x square plus 9. Now this under root is for this x square plus 9 only, minus 5. Neither it can be factorized because this is unfactorizable. Now if I wish to evaluate the limit when the input or the x is approaching 4, for this function x square minus 16 divided by x square plus 9 under root minus 5. This cannot be done like this. So how do I do that? What I can do is I can multiply the numerator and denominator with x square plus 9 plus 5, because I need to cross validate, or I need to rationalize the denominator. That is why I am doing it x square plus 9 plus 5. When I do this, the limit then becomes limit x approaching 4, because I have multiplied the numerator and denominator with plus 5. So it becomes x square minus 16. Let the numerator be like that only. But when I multiply these two, these are the rationalizing parameters to each other, it becomes x square plus 9 minus 25, because these two have been multiplied, the denominators have been multiplied, but the numerator is still there. So I'll put it there, x square plus 9 plus 5. Now this can again be taken, or this can be simplified to limit x approaching 4. Now the numerator over here on this side is x square minus 16, and the denominator, because this is x square minus 16 again, so this becomes x square minus 16 into, because this was the rationalizing factor which we multiplied, plus 5. So these two values, because these two values are same, so they are cancelled, and this limit can be simplified. That limit x approaching 4 is now becoming under root x square plus 9 plus 5. So now I can directly substitute the value and find that it will be under root of 4 square plus 9 plus 5. Now this 4 square plus 9 becomes 25, and the under root of 25 again becomes 5. So the limit can be assessed as 5 plus 5 is equal to 10. This is neither substitution nor it is factorization. So there is another mode by which you can evaluate the limits, and that is nothing but rationalization. So there are three ways. Either you can solve the limits or assess the limits by substitution, which is the direct substitution. You can factorize and find the limits. But if these two are not available, you can do the rationalization by multiplying the numerators and the rationals of the numerators, and then finally evaluate the limits like this. So any happening around you would always be continuous. There cannot be any abruptness in the happening. Say for example, I kick this ball. Now this ball is moving and there will be continuous change in the distance. It cannot happen that at any given point of time this ball would have two locations. Means there will always be a continuum of change in distance from me with respect to time. We are going to look to the continuity in the coming lecture. I'll see you then. Thank you.